Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
What's up, guys? Welcome to the hands-on project for bash scripting. We have 12 examples here. We're going to go through each one by one. I'm going to describe what is going on in each example for you. We're going to get started with the while loop. So this is our first example here. So we're going to create a bash file with the name while_example.sh to know the use of the while loop. So in the example, the while loop will iterate for 5 times. The value of the count variable will increment by 1 in each step. And then when the value of the count is 5, then the while loop is going to terminate. So we have our setup here. We're going to go ahead and create this script and see how it works. So I'm going to go over to my virtual box here. I'm going to log in. There we go. Open my terminal. Yes, alright. So we're going to name this one. So we're going to open our text editor, Vim. Okay. We're going to name this one while example.sh. Let me adjust my screen here. There we go. Perfect. Okay. Oops. Alright, so Vim while underscore example .sh. That's going to open the text editor for us. I'm going to hit I for insert mode. We always start our scripts with the hash pling, which tells the loader what interpreter to use. So this is telling the script that we're using the bash shell. Okay. Now we're going to set up a first variable. It's going to be called valid. We're going to set that variable equal to true. Okay. So this variable is going to equal the true value. Okay. So when we're scripting, true and false is a very important concept to understand. Okay. So a variable can be true, or it can be false, or it can hold values, or it can hold strings. Okay. Or even numbers. All right. So in this case, we're not saying that the valid equals the word true. We're saying it holds the value of true, meaning this variable is true. We're going to see how that takes play in effect here in a second. We're going to set up a second variable called count. We are going to set that to the number 1. Okay. We're going to go ahead and start our while loop. So when we do while loops, we always start with while. And then we set up the first thing. So the first construct here. So we're going to say while variable valid. Oops, square bracket. We're going to say do. And notice when I type do, I put it in line with the while here. That's important. These need to be lined up, okay? So guys, like I said, this is holding the variable or the value true here in the variable valid, okay? So we're going to say while variable valid, which is in this case true. So while this is true, do echo. We're actually going to indent this, okay? Count, okay? So just like for loops, the commands you do are always indented away from the beginning of the statement, okay? So it's while this is true, do, and then the things we want to do are indented after it, okay? We're actually going to throw an if statement in here. So we'll say if, okay? And this is going to be in line with while, right? This is a new statement. So if, what we want to test, if variable count is equal -eq to 5, then break. Now guys, break here is a command. It's saying break the loop, right? Cancel the loop. And then we always end if statements with phi, which is if spelled backwards. So if statements, we always have our statement here, right? If whatever this is true, then do this, which in this case is break. Phi, end the statement, okay? Then we have one more thing we got to do. So we're going to use a double parentheses, count, plus plus. So guys, this is kind of unique. So what this is doing is it's taking our count variable, and these two plus signs are saying, hey, add 1, oops, I need to delete this space here, add 1 to the count variable every time that this while loop runs, okay? Now we need to finish our while loop. And how we do that is we say done, okay? So guys, spacing is super important when we're bash scripting, okay? So we have our statement while do these commands. If this is true, then do these commands phi. And we're closing our while loop here. So you close a while loop with the done phrase, okay? So this if statement is part of this while loop. So we got to close all this out. So the if statement was closed, okay? So this was closed out with phi. Now we got to close this while loop, which is done. Okay? So valid is equal to true. So while this is true, and this is always going to be true because we set it to true, do this. Okay? So how we escape that is we set the count variable, this one, equal to 5, then break it. When that becomes true, then this is going to break the while loop. Alright, let's try that out. So I'm going to do escape, right quit to save this. I have to make it executable. Okay. While underscore example .sh. So now it's executable. There's two ways you can run a script. You can do a / as long as the script is in your current directory. And if I do an ls, you'll see there it is. Okay. So since it's in my current directory, I can do a / while example.sh. Okay. And there you go. You see it runs it 1, 2, 3, 4, 5. The count variable finally equaled 5, so it broke the while loop. Okay. If we didn't have that if statement in there, this would just go on forever and ever and ever, just adding 1 to it each time. The other way you can run a script is you can actually use the bash command and then your script name. Okay. Now keep in mind that you're going to have to give the full path if this script is still not in your current directory. If this was in another directory, I would have to give the full path to that script. And there you see it runs the script just the same as using /. Okay, so that is how you would run the while loop. Let's move on to example 2 here, which is using a for loop. So the basic for loop declaration is shown in the following example. We're going to create a file and we're going to name it for example.sh. We're going to add the following script to it. So here the for loop is going to iterate 10 times. It's going to print all values of the variable counter, which is this variable here, and it's going to do it in a single line. Okay, let's head to our virtual box. So I'm going to use the text editor vim again. I'm going to do for underscore example.sh. So now I'm in my editor. I hit I for insert mode. We always start with our hash pling, which is hashtag or # exclamation point bin / bash. Guys, we can also do Korn shell, Z shell, fish shell here, okay? But we're going to use the bash shell because that's the most common. We're going to say for, so we always start for loops with the word for. And in this case, we're going to use a unique type of for loop where we use 3 expressions, okay? So we're going to start with the double parentheses. We're going to do counter variable equals 10, okay? We're going to use semicolon, counter greater than 0. Okay, we're going to do semicolon again, and we're going to do counter minus minus. So we saw in the previous example how ++ adds to the variable and increments it by 1. Oops, I need to get rid of that space. In this case, it's going to subtract it by 1. Okay, we're going to close out that double parentheses. Okay, and then we're going to do do, and notice again do lines up with the for. All right, and now we're going to put all the commands. It's going to be indented echo -n quotation mark and then variable counter. Remember, variables always have the $ in front of them. That's how we know we're a variable. Okay, we put a little space here because we want spaces in between each of these variables, and then we do done. That's how we close out a for loop. All right. So while is closed out with a done, for is closed out with a done, and if is closed out with a fi phi. Okay. And then we're gonna do one more thing. We're gonna say print f quotation mark \n quotation mark. All right. So this is an escape character or end of line character. So we're just deleting those end of lines there, okay? Or we're printing the end of lines there. And we're going to see what that looks like here in a second. All right. So we're saying for variable, or we're saying for the counter variable is equal to 10, and while is greater than 0, we're going to subtract 1 from it each time, okay? So we're saying equal to 10, it has to be greater than 0, and we're subtract 1 from it each time. So once it isn't greater than 0, then it's going to finish, okay? So let's see what happens here. So we're going to escape, right quit. We have to make it executable. So chmod all plus executable for underscore example dot sh, and we're going to run it. So bash for underscore example. So we're executing our script here, and there you go. So you see it prints it each time, and then once it got to the 0 part of it, right, it has to be greater than 0. So when it got to that, it stopped, right? Because 0 is not greater than 0, so it stopped there. And it printed it in a single line, which is what that \n was, right? That is the new line phrase. All right, I'm going to show you a couple other ways that we can use the for loop, okay? Which are a little bit more common. Typically, this is how for is going to be used. You're going to do for I in this case we use 1, 2, 3, 4, 5, do echo well, which is I times. So what would happen here is it go welcome 1 time, welcome 2 times, welcome 3 times, welcome 4 times, welcome 5 times, and then it would stop. So this I is being used as a variable, and it runs through whatever you put here and places it in here, and done, okay? Same thing going on here, except we're using the sequence command. Now keep in mind, guys, this is deprecated. What deprecated means is that it's not used anymore. It's old. It's an old version of, or old way of doing something. So I wouldn't do it this anymore. This does the same thing as this, right? It does 1, 2, 20, okay? So use this version instead, but just be aware that you may see this, and this is what it does, okay? It's the same thing as up here, except it does welcome 1 time, 2 times, 20 times. Okay, and same thing down here. Actually, yeah, this is the exact same thing up here. Okay, guys, typically what's going to happen is, so how I would use a for loop is I would actually do for I in, and I'm going to put a bunch of host names of servers. I'm going to say do, and then I'm going to put a bunch of things I want to do to these servers. What it's going to do is it's going to do, okay, on the first server, it's going to do all of this stuff, and then it's going to go to that next server and do all the same thing, etc., for however many host names or IP addresses I put here. That's typically how you're going to use a for loop, and that's why it's super useful. In example 3 here, we're going to be looking at getting user input. So we use the read command, and this is used to take input from the user in bash and store it in a variable. So we're going to create a file named user_input.sh. We're going to add the following script to it. So here we're going to take a string value, which is going to be taken from the user. We're going to display that value by combining other string values. Okay, so let's check that out. Head on over to our virtual box. I'm going to clear my screen. We're going to use the text editor Vim, and we're going to name it user_input.sh. Hit insert mode. I'm going to put my hash plane at the beginning, just as we always do when we're writing a script. I'm going to put echo, which is going to display the following output to the screen, right? Enter your name. And then I'm going to use the read command, and whatever I put after this read command is going to store whatever the user puts into the variable. So whatever comes after this read command is your variable, and it's going to store the user input into this variable. In this case, we're going to name it name, okay? So now this is a variable, and it takes the user input and stores it in the variable name, okay? And then I'm going to echo welcome variable name to intro to bash scripting.
Thanks for watching. Feel free to add your questions as comments down below.
And that's it. Simple script. I'm going to escape right quit. Okay. Now keep in mind, guys, that this variable has to equal this name, right? Or this variable name, otherwise it wouldn't work. So we're creating a variable here. It's taking user input, storing it in that variable called name, and then we're just displaying what the value of that variable is here, okay? To prove that, let's go ahead and make it executable. User underscore input .sh. Let's go ahead and execute it. So bash user underscore input .sh. Enter your name. Well, my name is Kevin. It's going to say, welcome Kevin to Intro to Bash Scripting, okay? So it asked me, sort of, you know, we just set up a string through echo, and it asked me, what's my name? And then when I put Kevin, that read command took this input, stored it in the name variable, and we see that here. Okay? So simple little command, but very, very powerful. Now we're going to be looking at using an if statement. So you can use the if condition with single or multiple conditions. So the starting and ending block of the statement is defined by if and fee. So we start with if, end it with fee, which is just if spelled backwards. So we're going to create a file named simple_if.sh with the following script. So here 10 is assigned to the variable n. And if the value of the variable n is less than 10, then the output will be it is a 1-digit number. Otherwise, the output is going to be it is a 2-digit number. So for comparison, -lt is used here. And we can also use the -eq, -ne, and -gt, which stands for equal, not equal, or greater than. And guys, when we use these square brackets, these are the expressions you want to use. Okay. When we're doing arithmetic, we use a parentheses or double parentheses, and we can use things like plus, minus, star for multiplication, not equal, you know, so exclamation point or equal sign, or equal, you know, double equal sign, or just an equal. Okay, so double parentheses allows you to use those characters as actual arithmetic, and they won't be interpreted as other things. Okay, so let's check that out on our virtual box here. I'm going to go ahead and clear my screen. We're going to enter and use the Vim editor. We're going to name this if. Got to double check what the name is. Simpleif.sh. So simple_if.sh. I for insert mode. Always start with our hash string. So we're going to set a variable n equal to the number 10. We always start if statements with if, and then our statement that we want to check, whether it's true or false. So that's how if statements work. We're checking if this statement is true or false. Variable n is -lt for less than 10. Close the square bracket. We put a semicolon, then we do then. And then it's going to indent it for us because we're putting commands. Echo, it is a 1-digit number. Else, so on if statements we can have an else, and we can do as many else's if we want, okay? We're going to say echo, and I'm going to explain what that means here in a second, is a 2-digit number. And then we end it with fee, which is if spelled backwards, okay? Excuse me. So we're saying if this is true, so if variable n is less than 10, then do this. Else, if it's not true, then do this, okay? I could also put another else. I could say, you know, that would mean if this is true, then do this. Else, if that's not true, then do this. Else, if neither of those is true, then do this other thing, okay? So we can actually keep this if statement going, okay? We don't have to just do 2 parts to it. I can add as many parts as I want to these middle parts until something is true. Okay, so let's go ahead and make this executable, see what happens. Check out our script in action. So all plus executable simple if.sh. Let's execute it with the bash command. So simple underscore if.sh. So it is a 2-digit number. Okay. Why did that happen? Well, as we see here in our script, n, which is equal to 10, is not less than 10, right? 10 is not less than 10. So that statement is false. So if this is true, then do this, right? If this is true, do this. It is not true, so else we did this. It is a 2-digit number. Okay? So we're looking at example 5 here, where we're using an if statement with AND logic. So there's different types of logical conditions that can be used in an if statement with 2 or more conditions. So here we can define multiple conditions in an if statement using the AND logic shown in the following example. So when we use the AND logic, guys, it's a double ampersand. That's what these symbols are called. And it's used to apply the AND logic to an if statement. So we're going to create a file named ifwithand.sh. And the value of the variable username and the value of the variable password are going to be taken from the user and compared with admin and secret. If both values match, then the output would be valid user. Otherwise, output would be invalid user, okay? So there's a lot going on here, but it's not as complicated as you think. So let's check it out on our virtual box. So we're going to use the actually, let me clear my screen real quick. So we use the text editor Vim. I'm going to give it this huge name, if with and .sh. I hit I for insert mode. I'm going to do X, or I'm going to enter my hash plane /bin/bash. This is always what you start your scripts with. Oops. I'm going to go to the next line just to make it look nicer. So I'm going to do echo, enter username. We're going to use that read command that we just learned about in a few examples ago. And we're going to name the variable username. So it's going to take the input from the user and store it in this variable username. And then we're going to do another echo and say enter password. Okay. We're going to use that read command again. We're going to take the input from the user again and store it in a variable called password. I'm going to hit enter twice just so my script looks a little bit nicer. Guys, these spaces in between things don't matter. When scripts are run, it reads it line by line. So it reads this line, then this one, then this one, then this one, then this one, and so on and so on. So putting blank spaces in between your lines doesn't matter. It's just going to see that line is blank and head to the next one. So it just looks nicer to kind of separate things. I'm going to do a double square bracket, and then I'm going to do a parentheses. And I'm just going to type all this out, guys, and then I'll explain it once we got everything set up. So if username is equal to, we use a double equal sign to mean equal to, the string admin, okay? And then I'm going to close out that parentheses. And, so double ampersand, parentheses, the password, or the variable password is equal to secret, the string secret. I'm going to close out the parentheses. I'm going to close out that whole statement with double square brackets, semicolon, then echo valid user. Else echo invalid user. And we end the statement with feet. Okay. Oops. Feet. Ooh, what happened here? Oops. The spacing is actually off. Alright. Else. There we go. Fix spacing. Oops. There we go. Alright. We want all that nice and lined up. Okay. So let's explain what's totally going on here. So we have our if statement. Now we use double square brackets because we want to encapsulate everything that's going on here. Okay? So we want to encapsulate this as one single statement. Now the reason we used these parentheses here is because we also wanted to close each of these as kind of their own little part. If I didn't use these parentheses here, okay, it would kind of see all this as one statement and it would try to interpret things together. So it might It might say, hey, admin and password have to be part of each other, or maybe, you know, it's just reading this whole thing as one line, and we don't want that, okay? We want each of these. We want the variable password to equal secret and the variable username to equal admin to be their own things, okay? But we want the statement as a whole to be a single thing. We want this whole statement to be true, and that's why we use double brackets to encapsulate it, okay? So remember, parentheses are used for arithmetic, and in this case, we're saying we want these equal signs to mean equal, okay? And brackets are used to test expressions, meaning is it true? We're testing things against each other. Brackets are used to test expressions whether they're true or false. So that's why we're using square brackets to test these statements to see if they're true or false. Parentheses is being used in this case to see if the username variable is going to equal admin. And then the double ampersand sign is and logic. So this whole statement can only be true if this first part is true and the second part is true, okay? If they are, then it's going to echo valid user. If one of these is false, then the whole thing's going to be false if we're using and logic, and else it's going to echo invalid user, okay? So let's check that out. We'll do escape right quit. We're going to make it executable, so chmod all plus x if underscore with underscore and dot sh. We're going to execute it with the bash if underscore with underscore and dot sh. Enter username. I'm going to do admin. Enter password, secret, invalid user. Let's see, what did I... Aha! So here's what happened, guys. I spelled secret wrong. So remember, this is a literal string. If I do not put this letter for letter, then it's going to say it's false. So I need to spell the word secret correctly. There we go. So now I'm going to do right quit. We're going to try that over. Let me clear my screen. So we're going to do bash if underscore with and sh admin secret. There we go. Okay, so with proper spelling, it'll work correctly. So let's head back to our project real quick. So it took the user input from me, stored it in username, and it took the user input from me and stored it in password. Username did equal admin. Password did equal secret, so then it echoed valid user, okay? Let's head back to our VirtualBox real quick, and I'm going to show you what happens when I make one of them false. So I'm going to execute that script again. I'm going to say, hey, actually, my name is Kevin. That's my username. My password, well, I'll make it secret. Invalid user, right? One of them was false, so the whole thing was false, so it echoed that second part, right? So that is how you can use multiple expressions and statements in an if statement. So that was how we use an if statement with or logic. We're gonna, and logic. We're gonna check out how to use an if statement with or logic now. Okay, so we just checked out how to do it with and logic. We're gonna check out how to do it with or logic now. So the double pipe symbol is used to define the or logic in an if condition. Okay. So we're gonna create a file named if underscore with underscore or dot sh with the following code. So here the value of in will be taken from the user, and if the value is equal to 15 or 45, then the output will be you won the game. Otherwise, the output will be you lost the game. So guys, the difference between and logic and or logic is in and logic, both statements have to be true for the whole thing to be true. Or logic, only one of them has to be true for the whole thing to be true. So let's write that up here. Let's head to our VirtualBox. We're going to use the Vim editor. We're going to name the script if with or dot sh. So if underscore with underscore or dot sh. Insert mode. Always put our hash bling at the beginning of our scripts. Oops. I'm going to do echo. Enter any number. And we're going to use that read command. And we're going to assign that user input to the variable in. I'm going to start my if statement. I'm going to do a double square bracket again.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Because we're testing statements here. I'm going to use a parentheses again. We're going to say $n for variable n dash eq for equal 15. So if n is equal to 15, in parentheses, or double pipe symbol, parentheses again, variable n dash is equal to 45, eq 45. I'm going to close out that parentheses. I'm going to close out our whole statement with a double bracket, semicolon, then echo, you won the game. Else, echo, you lost the game. And we're going to close out that if statement with fi, so fi, which is if spelled backwards. We're going to right quit. We are going to make that executable. So chmod all plus executable if underscore with underscore or dot sh. We're going to run it. If underscore with or dot sh. So it's saying enter a number. Let's do 15. You won the game. Let's do it again. This time we're going to enter 45. You won the game. We're going to run it one more time. We're going to enter 33. You lost the game. So let's check out that script again. If, with, and see what went on exactly. Okay. So, just like our last example, we encapsulated this whole statement with double brackets, all right? We're checking this whole statement whether it's true or false. We encapsulated each part of it with parentheses, okay? And then we used the double pipe symbol for or. So we wanted to see if the user input that was stored in the n was greater than, if it was equal to 15 in this first part, and we wanted to see if that user input stored in the variable n was equal to 45 in the second part. So if this statement is true, then do this. You won the game. Else, echo, you lost. And again, as I said, in OR logic, only one of these needs to be true for the whole statement to be true for this echo to happen, which we saw. Right? First, I typed in 15 here. Okay, so, all right, well, that was true. So the whole thing was true. So echoed, you won the game. The second time, I typed in 45. So, okay, 45 does equal 45. So because one of them was true, the whole thing was true. So echoed, you won the game. That third time, I typed in 33, right? Well, 33 is not equal to 15. 33 is also not equal to 45. So it was false as a whole. The whole statement was false. So it echoed, you lost the game. Okay? So that is how OR logic works in comparison to AND logic. Now we're going to check out how to use the else-if statements. We're going to draw out these if statements, all right, to have multiple lines. I kind of mentioned this earlier about how you can add multiple else statements, okay? And we're going to check out how to do that now. So the use of the else-if condition is a little different in Bash than other programming. So we kind of shorten that else-if to just elif, and it's used to define the else-if condition in Bash. So we create a file named elseif underscore example.sh. We're going to add the following script to that file to check how else-if is defined in the Bash script, okay? Let's scroll down a little bit here so we can see the full thing. Okay? So we're going to head to our virtual box here. I'm going to clear my screen. Vim, we're going to name this script elseif underscore example.sh. So else if underscore forgot the name again. It's example. Okay, else if example underscore .sh. Example.sh. You hit I for insert mode. I'm going to add my hash plane at the beginning, just as we always do with every single script we write. I'm going to say echo, enter your lucky number. And then we're going to use that read command we've been using the past few examples. We're going to store user input in a variable called in. We're going to say if. We're going to use square brackets because we're comparing a statement here. So we're saying if variable in is equal to 101, so the number 101. I'm going to close out that statement, use semicolon, and then echo, you got first prize. elif, or else if, elif. Now I'm putting another statement here. So I'm using square brackets. The variable in is equal to 510. Semicolon, then echo, you got second prize. Now I'm going to use another elif statement here, so I'm adding a third statement. Variable in is equal to 999. Then echo, you got third prize. Else, echo, sorry, try for next time. And I'm going to close out my whole if statement with fee, okay? So let's check out what's going on here. And actually, I need to correct the spacing on these. There we go. I need to correct that. So guys, Vim is very nice because it colors things, so it kind of shows you when things are off. There we go. Okay, so let's check out what's going on here. Well, echo, simple enough. We understand that. We've used the read command. We're familiar with an if statement, so we're saying if this is true, if n is equal to 101, then echo this. Now we're using elif, right? So, if this is true, then do this. Else if this is true, then do this. Else if this is true, then do this. Else, if none of that is true, then do this. So basically, we're checking this first statement to see if it's true, and if it is, it's going to echo this. Then we're seeing if this statement is true, then do this. Then we're seeing if this statement is true, then do this. Else, if none of that is true, then we're going to echo this. So let's check that out in action. We're going to make it executable. Else, if underscore example .sh. We're going to execute it with bash. Else, if underscore example .sh. Enter your lucky number. Let's do 101 first. All right, you got first prize. Let's run it again. Let's do 510. Second prize, not bad. Second place isn't bad. Let's run it a third time. We're going to do 999. Third prize, okay, top 3, still not bad. Let's run it one more time. We're going to do, say, like 455. Oops, I got to execute the command. There we go, 455. Sorry, try for next time. Boo, I didn't win. All right. So let's go to our homework and check out what happened here. So first I typed in 101. So the first if statement was true, so echoed, you got first prize. Then I ran it again and I typed in 510. Okay? So the first one was not true. 510 does not equal 101, so it went to this next part. 510 does equal 510, so this part was true, so echoed, you got second prize. Then I typed in 999. Well, 999 is not equal to 101. This statement is false, so it skipped it, went to this next one. 999 is not equal to 510. This part was false again, so it skipped this, went to the third statement. 999 is equal to 999, so echoed, you got third prize, okay? And then on that fourth and last one, I typed in 455, okay? So 455 is not equal to 101, 510, or 999. So it looked at this statement, else, echo, sorry, try for next time. So all these were false, so it went to this one, it just said, hey, echo this. So that's how we can keep an if statement going. We can use those elif statements, and we can add as many of those as we like in our if statement. We're going to look at an entirely new way to write a bash script, which is a case statement. So a case statement is used as an alternative to the if, else statement. So the starting and ending block of this statement is defined by case and is ended with esac. So just like if, we spell if backwards for fee to end it, and case, we spell case backwards, esac, to end that statement. So we're going to create a new file named case_example.sh. We're going to add the following script to it. So the output of the following script will be the same to the previous else if example. Okay, so we're doing the same thing as in the previous example, but now we're using the case statement to do that. All right, so it's very odd looking at first, but it's going to make sense as we start to write it here. So vim case_example.sh, insert mode, so hit I for insert mode. Just as we always have, we're starting it with our hash plane. We're going to say echo, enter your lucky number. We use that read command to store the user input into the variable in. Now we're going to start our case statement. We always start the case statement with the word case. And kind of like a for loop, we're going to use the variable in and then the word in. So case variable in, and we're going to do 101 parentheses, and we're going to line that up with case echo you got first prize. 202, or I'm sorry, 510. We're going to line that up with 101, and I forgot to put parentheses here. Okay, and then we're going to do echo you got second prize. Then we're going to do 999. Oops, 999. We're going to line that up with the rest of them. We're going to indent. We're going to do echo you got third prize. Finally, we're going to do a splat or star symbol to mean all or everything, okay? We're going to indent it. We're going to do echo, sorry, try for next time. And then we're going to end it with esac, which is case spelled backwards, okay? So let's look at what's going on here. So basically, this case statement is taking this variable and it's running through these values. So is in 101, if it is, it's going to echo this. Is in 510, if it is, it's going to echo this. Is in 999, if it is, it's going to echo this. Everything else, so any other number besides these three, it's going to echo this. Let's check that out. So we're going to do escape, write, quit. We're going to make it executable all plus x case_example.sh. We're going to run that script with the bash command. Oops. Enter your number, 101. Actually, let's go back to that script. Let's see what I mislabeled. Guys, I forgot a very important part of this, which is this little character here, okay? We need to these statements with a double semicolon.
Thanks for watching. Please like and share this video.
Okay, this is how you end each one of these statements and how it knows that it's moving on to the next statement. Okay, so just like when we do a if statement and we put a semicolon after the statement and then we do then do this, okay, that's how this case statement works. So we use it 2 semicolons. So 101 double semicolon, 510 double semicolon, 99 double semicolon, everything else double semicolon ended. Okay. And you see now that these colors actually match up finally. Okay, that should have been a sign to me that something was off. Alright, now we're going to run it. Enter your lucky number, 101. You got first prize. Let's run it again. 510. Second prize, not bad. One more time. 999. Third prize, well, alright. Third still isn't bad. Top 3. We're going to run it one more time. I'm going to put 1, 2, 3. Ah, boo, I didn't get anything. No prize for me. Let's check that out. So, basically it looked at, is in 101? If it is, you got first prize. Is in 510? You got second prize. Is in 999? Well, then do this. And then we use this star symbol. Remember, star in regular expressions or meta characters means all. So everything else but these 3 will run this. So that is what the case statement does and how it's used. Alright guys, the rest of these examples are going to be working with functions. So the first one, we're going to look at how to create a function. And we're going to look at how to call the function in the following script. So we're going to create a file named function_example.sh and we're going to add the following code to it. So you can call any function by name only without using a bracket in a bash script. Okay? So this is a very simple function. Let's go ahead and write it out here. Head to our VirtualBox. We're going to enter that Vim editor. We're going to name it function_example.sh. Insert, start it with the hash plane, which is the proper way to start any bash script. So this is kind of an older way to do functions. So you use the function command, which is reserved for functions, and then you put the name of the function. Use double parentheses, so left and right parentheses. Then we use the little squiggly or curly brace. Okay, and when I hit enter here, we're going to be in the body of the function now. So echo. So I'm actually indent that echo. We're going to use single quote I like bash programming. Single quote. And then we're going to close out that function with the curly brace again. Okay. Oops. I need to spell this correctly. There we go. Function F1. There we go. All right. Now I'm going to call the function. Guys, it's important when you write up a function, you need to call it afterwards. Okay? Otherwise, it's not going to execute. So, when we do functions, if we're going to use this method, we use the function command, we name it with F1 and then double parentheses, and we do a curly brace, and then now we're in the body of the function here. And we can type as much as we want in here. I can add as many lines in between these curly braces as I want. Right? I can put a bunch of stuff in here. And then I close it out with the curly brace, and that curly brace, when we close it out, is lined up with the word function. Okay? Spacing and indentation is so important when we're doing these bash scripts, guys. If you have that off, it doesn't line up, it's gonna break, it's not gonna work. So it's very important how we line those up. And then you need to call the function after you've written it in order for it to execute. So let's do escape right quit. Let's make it executable so we can run it. Run it. Okay. Now we're going to run it. Do bash function. Example sh. I like bash programming, right? Okay, so that was a very simple function, right? All we had the function doing is just echoing I like bash programming. Simple enough. And that is how you write a function. Now we're going to make our function a little bit more intricate, and we're going to add parameters to it. So bash can't declare function parameters arguments at the time of the function declaration. Meaning when we declare the function, we can't add arguments or parameters to it. Okay? But you can use parameters in function by using other variables. So if two values are passed at the time of the function calling, which is right here, this is when we call the function, then the variable 1 and variable 2 can be used to read the values, all right? And we've seen this in our course, right? When we pass arguments to a script, remember these variable 1 and variable 2 symbols are used to hold those values. So we're going to create a file named function underscore parameter.sh. And we're going to add the following code to it. So here the function rectangle area, that's the name of the function, is going to calculate the area of the rectangle based on the parameter values added to it, which is going to be 10 and 20. Let's write that up. So vim, we're going to name it function parameter underscore parameter.sh. Insert mode, hash bling. Now, this is the more modern way to call a function, guys. Or to, I'm sorry, not call a function, but to write a function up. So we just give it the name in double parentheses, okay? I could put function in front of this. Okay, but that's a deprecated method of doing it. We can just put the name in the double parentheses, okay? And then we open that function up with a curly brace. Now we're in the body of the function. We're going to say area. So the variable area is equal to variable double parentheses. So I said earlier when we're doing double parentheses, that's to use arithmetic, and that's exactly what's going on here. So variable 1 times. So now the star or splat symbol is not going to be interpreted as all, but instead multiplication. Variable 2. I'm going to close out that arithmetic expression. I'm going to say echo area is colon variable area. So it's going to display the value of that variable area. Okay. In this case, the value is going to be whatever we pass to the first argument and second argument. So those first argument and second arguments can be stored in this one, and this one it's going to be stored in this value, which is going to be assigned to this variable, and then we're going to echo that variable here. Okay. Now we need to close out the body of this function, so we do a curly brace. Okay, and it gets lined up with the function. And now again, it's super important that we call that function afterwards, and you call it by writing the name after it. Now we're going to give it two arguments, 10 and 20. So this 10 is going to get stored in this 1 here, and this 20 is going to get stored in this 2 here. Okay, we're going to right quit. Make it executable, all plus executable function underscore parameter. Oops, spelled function wrong. And we're going to go ahead and execute that. There you go, area is 200. So multiply 10 by 20, which is 200. And that's what we get. Now, guys, I could change these. I could put like 20. Oops. I could put 20. It's going to change the value, right? It's just putting 20 in that first variable, 20 in that second variable. Right? Now it's 400, right? So whatever I put as arguments to that function, it's going to store it in that first variable and that second variable. That's all this is showing. It's just how to create a function with parameters. Now, it might be silly right now. You're probably thinking, well, why wouldn't I just put 10 and 20 in there and have it multiply it? Well, sometimes maybe you want a script that has some versatility. You know, you want to be able to just put whatever you want in there, and it just calculates it for you, right? It might not always be 10 and 20 that you need it to calculate, so it's nice to be able to have some versatility in your script. So example 11 here, we're going to look at how to pass return values from a function. So bash function can pass both numeric and string values. and how you can pass a string value from the function is shown in the following example. So we're going to create a file named function_return.sh and add the following code to it. So the function with the name greeting is going to return a string value into the variable val, which prints later by combining with another string. A lot going on here, guys, so we're going to take a little bit of time on this. It's going to be a little bit easier if I just write it all out and kind of explain it that way. So let's go to our virtual box here. Vim function_return.sh is what we're naming it. I'm hitting I for insert mode, throwing that hash pling in the beginning. Oops. And we're using that old deprecated method here, so we're going to say function, and then the name of the function, greeting. Okay. So this is the old method of using function. So we use the command function and the name. We could also just put the name of the function, which would work just the same. So now we've used curly brace to open up the body of this function. Now we're in the body of the function. We're going to say variable str is equal to hello, and then the variable name. We're going to echo the variable str, which we just set up. And we're going to close the body of this function. There. Okay, so now you're probably confused. You're like, well, okay, I see the str variable, but where's this name variable coming from? Well, we're about to find out. So echo, enter your name. We're going to use that read command that we've used several times in the previous examples here. So it's going to take the user input, store it into the variable name. Right? Now we have the variable name set up. Now we're going to set the variable value equal to the function. So two things is happening here. The function's being called, which is greeting, and we're assigning whatever the function greeting does to the value, or to the variable value. Okay? And then we're going to echo return value of the function is variable val. Okay? So let's look at what's going on here from the beginning. So we're creating a function. Inside the function, we're creating a variable called str, and we're saying make it equal to hello variable name, and then we're going to echo this variable here. Okay? After that, we're going to echo enter your name. It's going to take the user input and sort it into the value or variable name. Okay? So guys, this is actually happening before the function is being run. So once this happens, then the function's going to be run. And because this already happened, this variable exists. And it's being stored inside the function here at name, right? Now, the str variable has this stored in it. It says hello, and then whatever user input we put here, okay? And then it's echoing the variable str. So now we're at this point, right? Now it's echoed the variable str, and it's storing it in the variable val. Now we have a value assigned to the variable val, and we're echoing return the value of the function is the variable val. So let's see that in action. We're going to make it executable. And we're going to go ahead and run it. Enter your name, Kevin. Return value of the function is hello, Kevin. Perfect. That's what we wanted to happen. So what happened there? Well, we created this function. It asked me what my name was, and I put Kevin in, so it stored that value into the variable name. Then we called the function here, and as the function ran, it stored the variable name into this variable str and it echoed it. Okay, so now we're at this point.
Thanks for watching. Feel free to add your questions as comments down below.
So we have hello Kevin stored here in the variable val. Then we said echo return value of the function is val, which at this point is hello Kevin. Okay, a lot going on there, very complex. We just wanted to show how variables can kind of be interchanged here in functions. We also want to open your mind a little bit and get you kind of thinking in that scripting process about how powerful these scripts can be and how you can use them. Alright guys, so we're at our last example here. This one's a little bit different than the rest of them. All this example is showing is that you can use commands inside of your scripts and you can place commands inside of a variable. Okay, and it's going to use that command and take the output from that command and place it in a variable. So we're going to parse the current date. You can get the current system date and time value using the date command. And every part of date and time value can be parsed using capital Y, lowercase m, lowercase d, capital H, capital M, and capital S. So we're going to create a new file named date_parse.sh and add the following code to separate day, month, year, hour, minute, and second values. Okay, guys, when we say parsed, all that means is that we're kind of separating the text from a larger text. Okay, so we're grabbing a specific part of it and kind of refining it down to just what we want. Okay, that's a very loose meaning of what parsed is, but that's all what parsed really means, is that we're just taking a smaller part of what we want. So let's head to our virtual box here. Let me log in. Okay. Clear my screen real quick. I'm just going to run the date command just so you see what it does. So it gives us the day, month, year, and time. Okay, so I'm going to clear my screen. We're going to do vim. We're going to name the script date_parse.sh. We're going to go into insert mode, add our hash pling, just as we have for every other example and just as we will every time we're writing a bash script. So we're going to set the value variable year equal to, and we're actually going to use a special character here, which is a backtick, okay? This is located above your tab key or next to your 1 key, okay? This allows us to actually use commands inside of these little backticks, okay? If I didn't use this backtick, date would probably be used as a literal string if I used quotation marks, okay? So because I'm using backtick, it's going to read that as the actual date command. Now I'm going to do plus, percentage, capital Y. Oops. I guess I need to put the date command. That's important. There we go. Now I use plus percentage Y with the date command. It gives me the year in a very specific format. I'm going to close it out with backtick. Now I'm going to set the variable month equal to backtick date plus percentage lowercase m backtick. Then I'm going to set the day equal to, day variable equal to backtick date plus percentage d backtick. Set the hour variable equal to backtick date plus percentage capital H backtick. Minute variable equal to backtick date plus percentage capital M backtick. And finally, I'm setting the second variable equal to, just as you probably thought, date plus percentage capital S backtick. And then what I'm going to do is I'm going to echo date. So backtick date. So I'm actually echoing the date command. Okay, that's why I'm using backticks here. Then I'm going to echo current date is colon. I'm going to say the day variable dash. Okay. I'm going to do the month variable dash. And then the year variable, I'm going to close out that string. I'm going to do echo one more time. So this time I'm going to do it for the time. So current time is colon hour variable. Okay, and I'm actually going to use colons here because that's how times are usually formatted, right? So I want it to be formatted in a way that's familiar to us. So hour, and then minutes variable, colon, and then second variable, close parentheses, or I'm sorry, close quotation mark, okay? So now it's going to echo current date is, and then the day, month, and year variable, and on the second one it's going to echo the hour, minute, and second variable. Okay. Ooh, and I made one important and critical error here. Notice I put all these as lowercase. These should actually be uppercase, right? Because that's how our variable is spelled. Everything is case sensitive in Linux, so I need to spell it exactly as I did earlier. Otherwise, it won't know what variable I'm talking about. There we go. Perfect. Okay. I'm going to do it right quick. I am going to make that executable all plus x date underscore parse, and let's go ahead and execute it. Date underscore parse, and there you go. Oh, looks like I made another spelling error. Sure enough, right here, I put an S instead of a D. There we go. Alright, let's run that again. Bash date underscore parse.sh. There we go. Okay. So first thing it did, we said echo the date command, and that's what we have here. Oops. Right there. So Saturday, the 12th of September, 2020, 2 o'clock, 14 minutes, 40 seconds p.m. Central Standard Time. So then the next echo statement we had current date is colon day variable, okay, which is here. Month variable, which we set equal to date plus the month, which is this 09 here. Okay. Which we took from here. It is September, so 09. And then the year variable, which it's taking from here, from the date command, right there at the last part, 2020. Then we used current time is, and we took the hour variable, okay, which is 2. Okay. In this case, because we formatted it with the capital H, it took it in military time and not this time, right? So this is a little bit more user-friendly. It's how we're used to seeing it. This is military time here. Okay. Then we took the minute variable, which we see here, which is 14 minutes, which it took from that part of the date command. And then we took the second variable here, which was 40 seconds, okay? So guys, if we do a date dash dash help, you can see all these percentages and what they mean. Oops. So when we do date dash dash help, you see a lot of different ways to output it, all right? So we could actually use any of these percentages to format however we like. We just happen to use the ones we did, just for example purposes. So I'll clear my screen here. Okay. So that's how you would use commands to be used inside of variables. You got to use that backtick character, okay? And then we just displayed those variables here, right? Day, month, year, day, month, year, and then hour, minute, second, hour, minute, second. It was just taking the date command and a very specific part of that date command and putting them inside these variables, okay? So guys, that's it for this hands-on project. I hope you learned a lot. I hope you feel a little bit more comfortable with the bash scripting. Be sure to go to the end of those PowerPoints and check out those private tutoring sessions for Linux bash scripting and Linux system administrator management. There are weekly and monthly plans available. Get that extra help you need if you need it. Be sure to also follow those other resources you saw at the end of our PowerPoints. And be sure to follow us on social media, such as LinkedIn, YouTube, Twitter, and other platforms. And thanks for joining me, guys. This has been a project with coding-bootcamps.com. What's up, guys? Welcome to the grep hands-on project. So we're going to be finding strings and text files using grep with regular expressions. And we have 10 examples for that, okay? So grep is one of the most powerful tools for searching and finding strings in a text file. The name grep derives from a command in the now obsolete Unix ed line editor tool. The ed command for searching globally through a file for a regular expression and then printing those lines was g/re/p. And that's where the word grep is formed from, okay? So where re was the regular expression you would use, eventually the grep command was written to do this search on a file when not using ed. So in this tutorial, we're going to show you how to run advanced string searching using grep with regular expressions by giving you 10 hands-on examples on its implementations. So many examples discussed in this tutorial have practical implications, meaning you can use them in your daily Linux programming. The following samples describe some regex examples for commonly searched for patterns. Now guys, this word here, regular expression or regex, you're typically going to hear people say this as regex, okay, just meaning regular expressions, okay? One other important thing to note is that we are using a file here called book. Let me scroll down to that and show you. So we're using a file called book, okay? Book is available on the website coding-bootcamps.com under this course. Make sure that you download that and that you write that text file into your virtual machine so that you can run these commands, okay? You need to write it exactly as I have it written, exact spacing, capitalization, everything, okay? At the very least, you need to have it downloaded so you can at least cross-reference it and see how it's working against that file, okay? We're going to be using this book file for everything. So let's look at this first example here. We're just going to find a single character in a text file, okay? Now we're going to do that, and we're going to find the $sign character. Now, if we remember, $sign usually represents a variable, right? So what we need to do is we need to use this backslash character, okay? And this is how we escape special meanings of characters. Backslash is the escape character. And so what it's going to do is it's going to tell us, hey, this next character does not have a special meaning. Don't interpret it as anything else other than a literal string of $sign. Okay? So let's check that out. Got my VirtualBox here. Real quick, I am going to show you this book file. Okay? So here's the book file. This is what you need to have on your virtual machine, whether you pause the video here and type this out word by word, letter by letter, exactly how it is, or you download it from the website and do it that way. However you want to do it, you just need this file. Okay? I'm going to go ahead and clear my screen now. If you haven't done so already, go ahead and pause the video and type out this text file or download it from the website. I'm going to clear my screen now. So we're going to do grep space single quotation mark backslash, which is above your keyboard or your enter key on your keyboard, and then $sign single quote and then book. So grep, that's how it works. We use the grep command. Okay, what we're searching for and what we're searching in. Okay, I'll hit enter, and there you go. Now, you notice it gave me the whole line. So that's what grep does. It pastes the whole line that it found what you're searching for. In this case was the $sign, so it gave me that whole line. Okay. Let's check out example 2, which is finding a single string in a text file. So not a single character, but an entire string. Okay. Again, we're going to have to escape these special meanings here. So we're going to have to escape the $sign and the period sign, which of course are meta characters. So we have to throw some backslashes in front of those when we do grep, okay? So let's try that out. Now grep space single quote backslash, so don't interpret this $sign as a meta character, 1-4, backslash, so don't interpret this period as a meta character, single quote, and then on the book file. And you'll see this time, it still gave me the whole line, but it gave me the whole $14.99. Okay. Let's check out our third example here, which is find a single special character in a text file. So not just a normal character, but a special character, okay? Now this one's kind of funny because we're actually trying to find backslash Okay, so how we actually get out of the backslash is we put a backslash in front of it, which is ironic, right? So we're saying, hey, don't interpret this as...
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
The backslash, interpret it as a literal character, which is backslash. So let's check that out. Okay, so we're going to do grep, single quote, backslash, backslash, single quote, book. And there you go. We have one line in our file. It's backslash author Kevin Downs. Okay, I'll even show you that line here. There you go. It's this second line here. Okay, so that's the only line that has a backslash, and we can see it there. I'm going to go ahead and clear my screen. We're going to head back to our homework, or our project. So that's how you would find a special character in a text file. So now we're going to take a look at example 4, which is matching lines beginning with certain text. Okay. So in this one, we're going to use the caret symbol. It's hard to see here, but this is above the 6 key on your keyboard. And this is used in regular expressions to denote the beginning of a line. So in this case, we're going to output all lines that begin with pro. So we're going to look in the book file, and we want all lines that begin with the word or the letters pro. Okay, let's check that out. Let me cat book first. And you'll notice, well, here's all the beginning of the lines. Oops. There we go. So I cat book, we're looking at our file here. And I only see one line that begins with pro, right? And that's this one. So let's see what grep does. Let me clear my screen. So we're going to do grep, single quote, caret symbol, which is above the 6 key, pro, single quote, in book. And sure enough, it's going to give me back that pro line. We can also throw flags on grep, as we see here. A very common one is this -I, which means case insensitive. So we're going to output all lines in the file book that begin with the text in the beginning, regardless of case type. So case insensitive means, look, whether it's uppercase, lowercase, some uppercase, some are lowercase, I don't care. Just give me every single line that has this string in it, regardless of case. So let's try that out. So we're going to do grep -I for case insensitive, single quote, caret in the beginning. So all lines that begin with in the beginning, regardless of case. Single quote, book. We're going to hit enter. And there you have it. So it gave us the whole line. You'll notice this whole line is capital, but because I put the -I, it gave me it anyways. If I were to do that same command, so grep, no -I, single quote, caret in the beginning, book, aha, it didn't give it to me, right? Well, that's because this is all capital. If I'm going to do it this way, I would actually have to put in the beginning, single quote, book. I would actually have to spell it exactly how it is in order for grep to do it and find it the normal way. Or I can just do the -I, and then I don't have to worry about what the spelling of it is, right? We're not always going to know what the spelling of things are in files if we're trying to find something. Okay. Another important note, guys, is you're going to notice that these regular expressions were coded with a single quotation mark character, right? And this is because some shells otherwise treat the caret character as a special meta character. Okay? So we're using single quotes in all these because some of these have special meanings. So in addition to words and phrase searches, you can use grep to search for complex text patterns called regular expressions, which we've been seeing here. So a regular expression, or regex, is a text string of special characters that specifies a set of patterns to match. So technically speaking, the word or phrase patterns are regular expressions, just very simple ones. In a regular expression, most characters, including letters and numbers, represent themselves. For example, the regular expression pattern 1 matches the string 1, and the pattern boy matches the string boy. There are a number of reserved characters called meta characters that do not represent themselves in a regular expression, but they have a special meaning that is used to build complex patterns. These meta characters are as follows, which we've been seeing in some of our previous examples, such as period, star or splat, square brackets, caret symbol, $, and backslash. Okay, so we've been seeing those in our previous examples. Okay. It is good to note that such meta characters are common among almost all of common and special Linux distributions. So here you can follow a link, and it covers the special meanings of meta characters and gives examples of their usage. So just follow this link here. For now, though, we're going to go ahead and look at example 5, which is matching lines ending with certain text. So we're going to use the $, actually, as the last character of quoted text to match the text only at the end of the line. Okay. So here we're actually using the $, as a meta character, okay? It's not a variable, and it's a meta character, okay? And its meaning match the last character in the line, which is going to be exclamation point. So let's check that out in action on our book file. So we're going to do grep, single quote, exclamation point, $, meaning, hey, show me all lines that end with an exclamation point in book. Okay, we have exactly one line like that, but now you do exclamation point, exclamation point, exclamation point. Notice it only highlighted one exclamation point. Okay, and that's because we said we want all lines that end with an exclamation point. Okay, so it gave us the very last exclamation point. So that's what the $, is used for. It's used to match certain character spots in a line. Moving on to example 6 here, we're going to match lines of a certain length. Okay, so to match lines of a particular length, we use that number of the period character between the caret symbol and the $. Okay, so we're going to use 3 different meta characters here. So for example, to match all lines that are 2 characters or columns wide, we use caret, period, period, $, as a regex to search for. So we're going to do that now. On the book text file, we're going to use grep, caret, 3 periods, and a $. Okay, so grep, single quote, caret, period, 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 $, single quote, book. Okay, so this is giving us all characters that are all lines that are exactly 3 characters wide or long. In this case, we only have one, and that's pro, right? So let's go back to our homework. Now, we're going to look at some lines that are a little bit longer. Okay, but there's a more useful and simple way to do it. Okay, so for longer lines, it's more useful to use the different constructs. So in this case, we would do single quote, caret, period, backslash, the number, so curly brace, the number of lines or characters we want to match. I'm sorry, not the number of lines, but how wide we want it to be. And then another backslash, curly brace, $, single quote, okay? Guys, that's actually kind of a lot to remember. So we know the caret symbol means the beginning of a line, and we know the period means match the character spot, okay? But these curly braces are probably new to us, and we know that this $, means match the end of it. You're just going to have to remember this little construct here, right? It's a little too much to think about what each individual character means. You're just going to have to remember that this is how you set it up if you want to match something that's a certain length or width, okay? So we're going to look at how to do that with 12 characters here. So we're going to find lines that are 12 characters wide in the file book. So we do grep, single quote, caret, period, backslash, 12 characters wide, backslash, oop, and I forgot our curly brace here, curly brace in front of that first after that first backslash. There we go. And then we close out that curly brace after the second backslash, $, single quote, book. And there you go, we have exactly one line that's 12 characters long. Now you may be looking at this and counting and thinking, well, that's not 12, but remember, every single letter, space, and even this apostrophe here counts as a character, right? So we have 1, 2, 3 counting the apostrophe, 4, 5 counting the space, 6, 7, 8, 9, 10 counting the space again, and then 11, 12. So it actually is 12 characters long because the spaces and apostrophe count. Okay. Now the end, the space after the O doesn't count as a space. That's actually the end of the line. There is technically no space after that. So we're going to look at one more way to do that, and that's actually looking at 22 characters wide, all right? So we're heading back to our virtual box here. I'm going to clear my screen real quick, get some space back. So we're going to do grep, space, single quote, caret, period, backslash, curly brace, 22 characters this time, backslash, curly brace, $, single quote, on the file, book. So we have exactly one line in that file, and that is continue your learning. If we count that out, that is 22 characters long. So that's how you can search for certain lines that have a certain number of characters in them. Now we're looking at matching lines that contain any of some regular expressions. So to match lines that contain any of a number of regular expressions, you specify each of the regular expressions to search for between alternation operators, such as backslash or pipe, as a regex to search for. Okay, so we're going to do that on the file book, and we're going to look for either the patterns the book or cake. Okay, now guys, if we remember from our bash scripting, pipe does actually mean or, right? We would normally do a double pipe if we're doing a bash script. In this case, we're doing a single pipe, and it's going to mean or. Okay, now if we were just on the regular command line, pipe would actually feed the standard output of one thing into the standard input of the other, right? So that's actually why we're using this backslash character here, is we want to escape the normal meaning of pipe, and we want it to mean or in this case. Okay, so we're going to look for the patterns the book or cake in the file book. Okay, so let's go and do that. Grep, single quote, the book, backslash pipe, cake, single quote, book. And there we go. We find the book. We also find cake. Okay, in this case, we had both, so it gave us both. Okay. Now, if only one of these was present, it would still give me one of them, right? Because we're saying or. Find the book or cake. Okay, so that's how you're going to find any of some regular expressions. Now, instead, we're going to match lines that contain all of some regular expressions. So to output the lines that match all of a number of regular expressions, we're going to use grep to output the lines containing the first regular expression you want to match. And we're going to pipe the output to a grep with the second regular expression as an argument. You can continue to add pipes to grep searches for all the regular expressions you want to search for, okay? So guys, in this case, we're actually using pipe as it's intended. We're going to search for, using the case-insensitive option, the shore in book, and we're going to feed the output of that into another grep and say, hey, from whatever comes from that output, search only for sky. Okay, so we're looking for the shore, and then we want to find just sky. Okay. You'll also notice here that there's single quotes on this one, but not this one, okay? And that is because the shore is two words, right? We wanted to search for this whole phrase here. This is only one word, So we can kind of get away with that because, you know, grep's going to know that this is just a single word. If we use grep-i without quotes here, the shore, it might try to interpret it, one of these words, as...
Thanks for watching. Please like and share this video.
An argument or a flag, okay? So it's best to make sure you always put quotation marks on it. Even for sky here, the safe bet would be put single quotes here, but I just wanted to show you that sometimes you can get away with it here and not put single quotes, okay? So let's head to our virtual box. First, I want to show you that line in the book file, which is going to be this line here, this entire line, okay? You see, don't get stuck waiting on the shore. The sky is the limit for your learning, okay? So it's going to find this first part here. It's going to find the shore, okay? And it's going to give us this whole line. This whole line is going to be spit back, and then it's going to search for just sky from that whole line, okay? So let's actually do this one piece at a time. We're going to do just grep-i, the shore, first on the book file. And you see it gives us that whole line. Now we're going to do the second part with added in. Grep-i, the shore, on the book file. We're going to pipe that into another grep-i sky. Okay? So it's going to give us this whole line, and we're feeding that into the second grep, and we're saying, hey, from all of this, just find sky. And there you go. It says, here's sky in that line. Okay? So we fed this whole line into that second grep, and we found just sky. Okay, we could do that again and say, hey, just show us your. Okay, so I can add another pipe in grep-i. I could say, hey, just show me your or learning. And it's going to show me just learning. So we can add as many pipes as we want to find certain phrases. Now we're going to look at matching lines that only contain certain characters. So to match lines that only contain certain characters, we're going to use the regular expression caret. We're going to encapsulate the characters we want to find in square brackets here, and then star $sign. In this case, characters that are the ones we want to match. So we're going to look for A, E, I, O, or U in the book text file. And we're going to do it with a -i. We're going to say, hey, find all characters in the book file, or all lines that contain A, E, I, O, or U, which are vowels in this option. Okay. Let's check that out. Guys, since these are vowels, we're probably going to get a lot of results back, right? You need vowels to spell words, so we're probably about to get a lot of words back if I had to guess. Okay, so we do grep-i, case insensitive, single quotes, because we always want to encapsulate the string we're looking for in single quotes when we're using grep. And we're saying find all the characters A, E, I, O, or U inside these square brackets. So square brackets is how we look for certain characters. We hit enter. Yep, sure enough, we get tons of results back. But as you notice, it's only highlighting A, E, I, O, or U. I could do the same thing. I could do grep. Actually, let me clear my screen. I could do grep-i, single quote, square bracket, and I could say, hey, just find O, square bracket, single quote, book. There you go. It's going to give me every line that contains O. Notice some of these are double O's. And the reason it's giving me both O's here is because when we're going through a shell script or a text file, remember that it interprets it line by line, character by character. So it goes through this first line, it says, here's an O, and then it goes to the next one and says, hey, here's another O, and it keeps going and says, hey, here's an O. So that's why it's showing both O's in this case, is because it's looking at each one of those individually and it's saying, that's an O, and it's just highlighting it for me, okay? It wasn't searching for double O's. It was just searching for any O's. So that's a handy way to find only certain characters inside shell scripts or text files using grep. Alright guys, we're going to be looking at our last example here, which is finding phrases regardless of spacing. So one way to search for a phrase that might occur with extra spaces between words or across a line or page break is to remove all line feeds and extra spaces from the input and then grep that. So to do this, we're going to pipe the input to tr. We're going to do that with the single quote \r\n colon / greater than sign / pipe dash single quote. Okay? So a lot going on there, a lot of backslashes. We're going to put that as an argument to the -d option, removing all line breaks from the input, and we're going to pipe that to the FMT filter with the -u option, outputting the text with uniform spacing. We're going to pipe all of that to grep with the pattern to search for. Okay, so we have that here, guys. So we have cat book pipe tr-d single quote this format here. So \r\n colon / greater than / pipe dash. We're going to pipe that to fmt-u. We're going to pipe that to grep at the same time as. So we're finding at the same time as, and we're getting rid of all the extra spaces and page breaks. Okay. So what I'm going to do first is I'm going to show you that line. So cat book. So what we have here is we have other students have been following along, and we have a lot of spaces in between it at the same time as you. Okay, so let's see what happens when we run this. So the first thing we're doing is we're doing cat book. We're piping the output of this to tr-d single colon \r \n colon / greater than / pipe dash single colon, and then we're piping that to fmt-u, and we're piping that finally to the grep statement at the same time as you. Okay, so guys, what happened is we already outputted book, right? And we're chopping down all of that stuff. We're getting rid of all the extra spaces and lines. We're feeding that into grep. So that's why we didn't have to specify here on the grep statement book, right? We already outputted group the contents of book into this pipe, and it got fed into this. It chopped out a bunch of spacing and it fed that into this to give it uniform spacing, and it fed it into this, right? So what we're going to have as a result is a nice single line. Students have been following along at the same time as you. Okay, actually I noticed a typo here. We got one too many L's, right? So I guess that's another thing to know about Vim Editor. It doesn't show you typos, so you're going to have to be careful when spelling things. So let's head back to our homework, or our project, and let's summarize what we've covered. So in this article, we reviewed 10 practical examples of using grep Linux command for searching and finding strings in a text file. Along the way, we learned how to use regular expressions in conjunction with grep to conduct complex searches on text files. By now, you have a better idea on how powerful Linux search functions are. So here's some additional resources for those of you interested in learning more about Linux programming. I highly recommend following these guys and checking them out. We have 5 resources for system administrators, which are a Linux system admin guide for what is Linux operating system, how it works, an overview of Linux virtual memory and disk buffer cache, best practices for monitoring Linux systems, best practices for performing Linux boots and shutdowns, and best practices for making and managing backup operations. We also have resources for kernel programmers. We have 3 of those. We have our How Linux Operating System Memory Management Works, a comprehensive review of Linux kernel operating system processes, and what are mechanisms behind Linux kernel task management. We also have Linux File System Dictionary, so we have a comprehensive review of how Linux file and directory systems work. Oops. Okay, so be sure. My screen got stuck there. Sorry, guys. Be sure to follow those links. Continue your learning. Okay, because the more knowledge you have, the better off you're going to be. And I hope you had fun on this project, guys. This was a project from coding-bootcamps.com. Be sure to check out the end of those PowerPoint slides if you need a little bit of extra help. You can find those Linux and Bash scripting private tutoring sessions. Okay, there are weekly and monthly plans available. We also have ones available for Linux System Administrator Management. I'm looking forward to seeing you guys in the other homework and project assignments, as well as on our other courses. What's up, guys? Welcome to the homework portion of Intro to Linux Bash Scripting. So here we see we have 3 variables that need to be set, A, B, C, at 10, 20, and 30 respectively. Okay, so we're setting some variables and we're assigning a value to it. Okay, so what I want you to do is I want you to write a script to perform the following, and you're going to name it homework.sh. So first, if A is less than C, then echo hi. Second, if A is greater than B, then echo sunny, else echo snow. 3, if A is less than B and C is less than A, then echo possible, else echo sunny day, and so on. Okay, so what I want you to do, pause the video, go through these as best you can, and then once you feel like you're stuck and you're not sure what to do, then go ahead and unpause the video and we'll go through this all together. Okay, so guys, this is going to be a single script here. Okay, and each part is going to be doing something else. Okay, so each one of these is being defined as something else. Okay, so when you're done, you should have 5 different things echoed out to the screen. Okay, so again, pause the video, do as much as you can. When you get stuck or you're finished, unpause the video and we'll go through it together. Alright, hopefully you were able to do most of it, if not all of it, by yourself. If not, no worries, we're going to do it together right now. So this first one here, fairly simple. It says, if A is less than C, then echo hi. Okay, let's go and go to our virtual box here. So if A is less than C, then echo hi. Okay, so I'm going to open my terminal. Okay, CD to home. Let me make sure that homework.sh does not already exist. Looks like it does not. So we're going to go ahead and do vim homework.sh. Oops, I need to spell it correctly. I for insert mode, we always start off with that #bin /bash. So hashtag or # exclamation point /bin /bash. This tells the loader what interpreter to use. Okay, then we'll go to our next line here. If A is less than C, then echo hi. Okay, so we can already tell this is going to be like a if-then statement, or in this case, just an if statement. So we do if. Then we're going to use square brackets. Okay, remember square brackets are used to compare a statement. Okay, we only use parentheses or double parentheses when we want to do arithmetic expressions. Okay, in this case, we're just testing a statement to see if it's true or false. We're using square brackets. So if A, variable A, I forgot one important thing too. Hopefully you guys caught it. I need to set those variables. I need to declare them. So to declare a variable, I do it before the script. Before any of the if statements, I do A equals 10, B equals 20, and C equals 30. Okay, so variable A is equal to the value 10, variable B is equal to the value 20, and variable C is equal to the value 30. Okay. All right, now if variable A, and when we use square brackets, we have to use -LT for less than, or -GT for greater than, or -EQ for equal, or -NE for not equal. That's how we compare two variables in square brackets. So we're doing if A is less than variable C, close the square bracket. We need to close that off, right? We do a colon, semicolon, I mean, then echo hi. Okay? So it's going to check to see if this statement is true, then echo hi. And guys, A is less than C, right? 10 is less than 30, so we should see that it should echo hi, right? Okay. Let's go ahead and do an escape, right quit to save that file. And guys, remember spacing is important here as well, right? So on if then statements, we always put if.
Thanks for watching. Feel free to add your questions as comments down below.
The statement we want to check, and then on the next line, we indent it, and we always put whatever we want it to do if this statement is true. Okay? So before I can run that script, I have to do a chmod, make it executable, so all plus executable, homework.sh. Now I can say, hey, in this directory, execute this script. Oops, I need to spell it right. Keep misspelling that. Oops. Oh, I forgot one important thing. Sorry about that. One important thing, you need to end the if statement, right? How do you end the if statement? Well, you spell if backwards, fee, okay? And that gets lined up with this if, okay? So that was a mishap on my part. You always have to end it, and as you saw, it said, hey, there's an error here. The line ended, and we weren't expecting it to end, and that's because I was missing this fi. Now I'll save it and run it. And there you go. It says hi, right? Because A is less than C. So let's look at the second part of our homework, which is if A is greater than B, then echo sunny, else echo snow. Okay. Go back to our VirtualBox. Go back to our script. So I'm going to open that editor for homework.sh again. Oh, man, and I think I'm probably going to misspell that every time. So we're going to go to a new line because we're doing a new if-then statement. So if space, oops, square bracket, because we're comparing the statement again, variable A is greater than variable B. We're going to close that square bracket, semicolon, then next line, echo sunny. Else, and notice it's going to fix the spacing for us, so the else is always lined up with the if. Else, echo snow. And then we're going to put fee, which I forgot to do last time. So we always end the statement with fee. This is how it knows that this if statement is over. Okay? So what we're saying here is if this is true, okay, if this is true, oops, this part here, if this part is true, then do this. If it's not true, then do this. Okay? And is 10 greater than B? No. So what we should see is we should see it echo snow, right? Actually, we're going to see both of these, right? Because we have two statements going on. So we should see hi and we should see snow. Let's see, though. Let's see what happens. I don't have to make it executable, right? It's already executable. So I can do /homework.sh. Sure enough, I see hi and I see snow. Perfect. Let's check out number 3 for our homework. If A is less than B and C is less than A, then echo possible, else echo sunny. Oops. Need to make this a little bit bigger for you guys. There we go. See the whole screen there. Got cut off a little bit there. There we go. Else echo sunny day. So if A is less than B and C is less than A, then echo possible, else echo sunny day. Okay, let's go to our VirtualBox. I'm going to clear my screen. We're going to go back to our script here, which is homework.sh. So vim homework.sh. I told you I was going to spell it wrong every time. Work.sh. There we go. So we're going to start a new statement. So we're going to go to the next line here. If, square bracket, we're comparing a statement here. If variable A is less than variable b, and we're going to put a double ampersand sign, right, because we want to say and, so double ampersand sign, and when we do a double ampersand sign, both of these statements have to be true in order for the whole line to be true. So we're going to say square bracket, variable c, so and variable c is less than variable a, colon, and we, or semicolon, and we, oops, semicolon, and we close that square bracket, then echo possible, else echo sunny day. And we're going to end the statement with feet. Right? Okay, so here's what we got going on here. We're saying if A is less than B, right here, okay, and double ampersand symbol, C is less than A, then echo this. So this has to be true, and this has to be true in order for this command here to happen. Else, echo sunny day. Okay, so A is less than B, 10 is less than 20, and C is not equal, or is not less than A, right? 30 is bigger than 10. So this part of the statement is false. Therefore, this whole thing is false, right? So what we should see is sunny day should be echoed. So we should see hi, snow, sunny day, okay? Let's see. We're going to right quit. We're going to execute that script. So ./homework. Hey, I spelled it right first time this try. Sure enough, hi, snow, sunny day, right? Because that second part of the statement was false, so therefore the whole thing is false. When we use AND logic, both parts need to be true, or all parts need to be true in order for the whole thing to be true. Let's go back to our homework. We're going to look at number 4 here. If A is less than B, or, so now we're using OR logic, or B is less than C, echo hi, else echo goodbye. Okay? We're going to go back to our script here, vim homework.sh. Okay. I'll move my screen up a little bit for you here. Go to the next line. We're creating a new if-then statement. So if square bracket, comparing statement, A, we're testing statement, is less than B, or, so guys remember the OR symbol is a double pipe. Okay, OR is a double pipe. Square bracket, variable B is less than variable C, close the square bracket, semicolon, then echo hi, else echo bye. Right? Actually, it should be goodbye. There we go. Okay. So what we're basically saying here is if A is less than B, or, that's what this double pipe means, B is less than C, then do this, else do this, okay? So remember, on OR logic, only one of these needs to be true in order for the whole thing to be a true statement and to execute this first part, okay? If either part of these is true, then this first part here, the echo high, is going to get executed. If both are false, then goodbye would be echoed, okay? We only need one of these to be true, okay? Is A less than B? For sure. 10 is less than 20. Is B less than C? No, but this first part is true, so we should see a high, okay? So we should see high, sunny, I'm sorry, snow, right? Sunny day, goodbye. Okay, let's see. So we're going to do escape, right quit, Okay, we're going to execute our script. Okay, so /homework. So we should see hi, snow, sunny day. .sh, there we go. Oops. What did I forget, guys? Forgot to put phi again, right? Fi. There we go. So the reason that script didn't work is I forgot to end the statement, right? I forgot to put the fi to end the statement. The goodbye threw me off. I saw goodbye and I thought to myself, okay, goodbye, and I left the script. I forgot to put phi. So you have to end the statement with that fi. All right. Do save quit. We'll execute it again. And there you go. Hi, snow, sunny day, hi. Right? All right. Let's look at the last part of our homework here, which is if A is not equal to B and B is not equal to 40, then echo done. Okay, so now we have an and statement here. We have some not equals. We also just have a value to assign. Okay. So I'm going to clear my screen. We're going to go back to our script one more time here. Homework.sh. I'm going to move my screen up here so you can see the end part of that script. Alright, so you can see the bottom there. So I'm going to do if, square bracket, variable A is less than or I'm sorry, not less than, not equal. So remember when we're using these square brackets, okay, we have to do the -ne, not equal, variable B, square brackets, and so we're going to use that double ampersand again. Square bracket, and variable B is -ne not equal to just the value 40, so we can just put 40, right? We're just giving it a value, semicolon, then echo, done. And how do you have to end this? We want to end the statement with fi, okay? So let's save it. Let's do a right quit. Okay. Let's go and execute that. Homework.sh. Done. Okay. Hi, snow, sunny day. Hi, done. Okay. So let's go back to our homework. Actually, let's oops. Scroll up for you here. Let's just look at our script and see why each one of those did that, and just summarize kind of what happened. So vim homework.sh. Okay. So the first part here, the first if statement, we were just checking to see if variable A was less. Oops. Let me scroll all the way up here so we can see the variables. We were just seeing if variable A was less than variable C. 10 is less than C, so it echoed hi. In the second if statement, we said, okay, is variable A greater than B? A is not greater than B, so we echoed snow, right? If A is greater than B, then echo snow. Okay, so this was a false statement, right? That's why it didn't echo this. This has to be a true statement for it to do the first part. Else. So if this is true, then do this. Else, do this. If this is true, then do this. We only gave it one option here. Luckily, it was true. So on the third one here, we have if A is less than B and C is less than A, then echo possible, else echo sunny day. So if this is true and this is true, then do this, else do this. A is less than B, and
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
C is not less than A. So this was false all together. So if this is true and this is true, then do this, else do this. So that's why I echoed sunny day. Okay. You have our fourth if statement here. Let me scroll the page up a little bit. Come down. 1, 2, 3, 4. So we have our fourth if statement here. If A is less than B or B is less than C, then echo this. So if this is true or this is true, then do this, else do this. Well, A is less than B, that's true, but B is also less than C, right? So that's why I echoed high. Okay. We could also made this to where, we said if B is greater than C, then echo high. It still would have echoed high, right? Because one of these is true. We only need one part of it to be true. So the last one we looked at was the fifth if statement, which was if A is not equal to B and B is not equal to 40, then echo done. Both of those have to be true. So if this is true and this is true, then echo this. In this case, it was true, so that's why I echoed that. Okay? So there you have it, guys. That's the homework for you. 5 questions, 1 script. Hopefully you were able to do it on your own. If you need a little bit extra help, be sure to go to the end of those PowerPoints, follow those links for the private tutoring sessions for Linux System Administrator and Bash scripting. There are weekly and monthly plans available. Be sure to follow those other links for resources as well. Thanks so much for joining me, and I'll see you in our next session.